So these are the parts that we need for the flexural strength test, and I'm going to start to assemble them. The first thing is this little base. Base goes down under here. There's a bolt that will connect it, which here it is, it's in the drawer. So we'll put the bolt in here. We'll connect that, and then we'll start to screw this in. You can see I don't have a lot of room here, so I can move this arm up. Now I got a little more space, and we're going to tighten that. So now we've got this first piece in. Now we've got this is the second piece that goes with our flexural strength test. One thing in order to get this in here, we've got all these different parts, and you can kind of figure them out as you go. So that's one. Let's see. There we go. So if I was actually going to do this test, I would probably, I like it. It's easier to do if this is rotated. So I would have to take this apart, rotate this bottom stage, and then tighten it again. But for today, I'll just leave it like this. So I get this bottom pin in there, and then turning this knob will tighten everything up. And now this is the top part of the flexural strength machine. And so I'll lift it up. Now I got enough space. We've got to find another one of these. There's another pin that will fit inside of there. Here's one of these pins. And you can see it's not lined up right now. So a screw here that we can loosen. And now I can turn this until it lines up. And now I'll tighten the set screw. This knob needs to be tightened. And make sure everything's nice and tight and ready to go. These supports here, we have to make sure they're the right distance apart. We can measure them. We've got calipers here, and we can use to make sure that they're the right distance apart. So it looks like they're supposed to be 20 millimeters apart, and it looks like they're right about there at 20 millimeters apart. So that's good. And now, before we start testing, we got to go over to our testing software and get the program pulled up. So we go to Test, and we look through here, and the easiest way to do this is look for a previous test that that has already been used. So in this case, we see flexural strength test has been used recently. We click on this. We go to Next. I forgot we have to make sure that our load cell is calibrated, particularly if this is the first time we're using this load cell. So to do that, I'm actually going to take off this fixture that we just put inside, make sure there's nothing on the load cell, and then I go up to this button here, and I press Calibrate, remove load from load cell, which we did, and then we press OK. And it just takes about a minute, and it's going to calibrate our load cell for us. We don't have to do this every time, but we just do it every time that we've put on a new load cell. I just want to show you how it's done though. And then once it's calibrated, I'm going to assemble everything back together. So it says calibration complete. Okay, I'll put this back inside of here, make it good and tight, and done. So I want to, right now it's showing that there's 3 newtons of force on there, which isn't a big deal, but it just is registering the weight of this top piece here. So I press balance load, and now it's got the weight set at 0. The next thing that we want to do, we can go through and make sure that the test is running at the right speed. So we go to Method, Control, and now it says it's going at 1 millimeter per minute. And that's the correct speed that we want to run this test at. So we go back here to Test, and we should be ready to start this test. Alright, now we're ready to put the specimen into the flexural strength test. So we've got one of the specimen bars here, and what we're going to do is, before we put it in, we have to measure the dimensions, because even though the molds are the same, the specimens could be slightly different. So we measure one dimension, so this is 2.57, and we measure the other dimension, 2.49. So the one that's taller, in this case that time we measured 2. So now it's 2.50. Sometimes you have to make a couple different places of measurement. So somewhere around that 2.54. So that's the taller side. So whatever the taller side is, so this is the taller side, this is the way that it goes into the machine. So the taller side goes up and down, and the shorter side goes back and forth. So the taller side, we're going to put it in the middle between these two supports. And we want to make sure that it's perpendicular to this piece here, and in the middle, centered between the two supports. And once we get it in the proper position, the next thing we got to do is lower this indenter down till it's pretty close, but not touching. So when you get it pretty close, the closer you get it, the faster the test will go. But once you start getting it too close, you might accidentally break the specimen. So you can move this bar up and down with these buttons, or if you want to do just fine movements, you can tilt this wheel. So now it's pretty close to being on there, and now you can go ahead and you can either press start here, or you can press start on the machine. So we press start, and now the machine, this is going down at 1 millimeter per minute until it breaks the specimen. And it's going to record the force on the computer, and once it gets the highest force that it takes to break it, it will record that value. So it looks like the force is starting to go up. Once the specimen has been broken and the machine stops, we'll go ahead and load our next specimen, and we'll do that until we have all of our specimens broken, and then what we'll do is we'll go ahead and hit save, and we're done with all our specimens, and we'll hit finish, and we exit out of the program, and we'll be done.